All right, so we're going to continue our section on circles, and today we're going to talk about three different sets of angle relationships in circles. We've talked about central angles and inscribed angles. What's the difference between a central angle and an inscribed angle? So we just talked about inscribed angles on Thursday. What are inscribed angles? That's what we just did here. What's the difference between a central and an inscribed angle?
The central one is in the middle.
Central angle has its vertex in the center of the circle, right? And if it's a central angle, that means the angle measure and the arc measure are what? So like for instance, if this were here and this were 45, what would this be? Same. So a central angle, they're the same. In an inscribed angle, what's the relationship? Double. So if the angle is half of the actual measure of the arc, and the arc is twice the measure of the angle. So then, what do you know, like number 6, when you did number 6, how do you set that up? Why are they equal to each other? It's true that they are, but why?
They're inscribed. They have the same one.
They're both inscribed and they subtend the same arc. What arc do they subtend? DC. So they both subtend DC, and DC has to be the same as itself because of what property? What property is it that says like DC equals DC? Reflexive property. Because of the reflexive property, then they have to be the same. So everybody did this pretty well. 2x squared minus 2 equals 10x minus 2. Whoops, 10x minus 2. The only mistake I really saw people make is once you went back to plug in, if you did 2, which part of this do you have to do first? The exponents. You can't do 2 times 5 first. You have to do the exponents first. Order of operations tells us exponents comes before multiplication. So you end up doing 2 times 25, which gives you what? 50, and 50 minus 2 is 48. Good. Okay, so you end up with 48. If you plugged it into this one, that would also give you 48. 10 times 5 is 50. 50 minus 2 is 48. Thank you. So either one is going to give you 48. It doesn't matter which one you plug it into because they have to be equal to each other. Okay, so we're going to talk, like I said, about 3 different relationships. We're going to talk about tangent secant angles and tangent chord angles. And then we're going to talk about basically relationships made by either 2 chords or 2 tangents. So the first one is a tangent secant angle or a tangent chord angle. Essentially what a tangent secant angle is an angle that's made when either 2 tangents touch each other or a tangent and a chord touch each other. What is a tangent? Like which one of these is the tangent? BC. Why? It's outside the circle. It only touches it where? At B, right at B, right? Okay, and BA in this case, is it what? A secant or a chord? Why is it a secant? Because it's inside the circle and it touches it how many times?
2 times.
And then it does what? Keeps going. What if it stopped? Then it would be a chord. So the relationship is the same. The only difference is if AB keeps going, it's a secant. If AB were to stop like this, so that's still BC, and if this were AB, then this would be a tangent chord. So that's the only difference. There is no difference in the relationship, just in what you name it. This one's a secant, this one's a chord. So then this would be a tangent secant angle, and this would be a tangent chord angle. Okay, and remember that the tangent is always the one that touches it on the outside, so it just touches it one time. So either way, BC is the tangent. Alright, this angle relationship is exactly the same as an inscribed angle relationship, okay? So the measure of the arc, AB, is double the measure of the angle. So let's say AB were 80 degrees. How big is angle ABC? 40. So it's half the arc, and then the arc is double the angle. So if arc AB equals 80, then angle ABC equals 40 degrees. So that goes for tangent secant angles and tangent chord angles because, again, the only difference is that a tangent chord just stops, whereas a tangent secant keeps going. But either way, the arc is double the angle measure. So it's exactly the same as an inscribed angle. Okay? It's exactly the same as an inscribed angle measure. Alright, so how would you find BCD? The measure of angle BCD. Half of what? 142. What's half of 142? 71. So angle BCD would be equal to 71 degrees. What about measure ABC? Where is ABC? On the, it's an arc, right? And it goes from A to Z, or A to C, but it has to go through B. So that means we go from A all the way to C. So what angle goes with that?
180.
The 90-degree angle, which means the arc has to be 180. How else can you tell that? ABC is a, what is it called when it's half a circle? Semicircle. It makes up that semicircle. Okay, so it's a semicircle and it has to be double the angle, and since the angle is 90 degrees, it would be 180. So then using that, could you figure out arc AB?
Yeah.
How would you figure out arc AB?
180
minus 142, which would give you what? 38. So then could you figure out ACB? This angle?
Yeah.
Yes? What would that angle be? 38 divided by 2, which is 19. So measure ACB is equal to 19. So just keep in mind, once you have some stuff, you can figure out most of the other stuff. Okay. All right. So then the next section is two secants or two chords. So if they intersect in the interior of a circle, so if they cross each other inside the circle, basically forming what letter? An X. If they form an X inside the circle, E is not the center. So E is just a point where they intersect. It's not the center. All right. Then angle 1, which is the same as this one. So those two angles, you can figure out either of them the same way. How come these are the same? What kind of angles are those? They're vertical angles, so they have to be the same. To figure them out, you do the arc plus the arc divided by 2. So add the two arcs together and divide it by 2. Or another way of saying that is take half of the arc plus the arc. So if they meet inside, you add together AB and CD and divide it by 2. And that will give you angle 1 and also this angle over here. So those are both the same. All right, so for instance, in this example right here, if I want to figure out SQR, if I want to figure out this angle, how would I do it? Add what two together? Which gives you 132, and then divide by 2. Good, which gives you 66. Okay, so this angle is equal to 66, which means this angle is also 66. Okay? All right. If they meet on the outside, if it's two tangents or two secants, so if it meets on the outside, then instead of adding the two arcs, what do you think you do? Subtract them. You do the same thing, but you subtract the two arcs. So if the angle is on the outside, you would subtract the big arc minus the little arc, and then you take the half of that. Okay, so if it's on the exterior of an angle, so by two tangents, two secants, a tangent and a secant, if it's on the exterior of an angle, you do the big arc, so AD minus BD, and then divide that by 2. It's the same for all of these. So look at number or letter A down here. What would I do here?
124 minus 98. So they're mostly always going to give you the two.
They mostly will. We'll take a look at one that doesn't in just a second. So I'm going to do 76 divided by 2, which gives me what? 38? Yes, 38 degrees. All right, so angle X equals 38 degrees. All right, what about B? What about example B? What would I subtract here?
132 to.
I've got the little angle, right? The little arc. How would I find the big arc? It's not quite a semicircle because it's not straight up and down, but if this is 132, this arc would have to be
360.
all the rest of the circle. Why?
Because it's the circle.
Because it's two tangents, so it's the whole circle. So how would you figure out the rest of this? 360 minus 132. So start by doing 360 minus 132. So that means this is 228, and then from here, what do I do? Subtract those and divide by 2. So 228 minus 132 is 96, and then 96 divided by 2 is 48. So angle X equals 48. So Charlize, if they don't give you the other one, that's what it's going to be.
So you're always going to subtract it from
To start, subtract from 360. Yep. And then subtract again and then divide by 2. So how do you know if you add the arcs or subtract the arcs? Well, if they give you both, when do you add them?
One's X.
If it's an X, where? Inside the circle. If the angle's inside the circle, when do you subtract them? If that angle is outside the circle. So if it's a tangent and a secant, or a tangent and a chord, or something, so that the angle is outside the circle. Sorry, tangent and a secant. Okay, try these. The first three guys are just matching, so before you get up, for the first three, you're just matching 1, 2, and 3 to A, B, or C. Which formula would you use for those? And then for the next ones, you're actually doing them. All right, so then the last thing is how can we put that all together to find different pieces of missing arcs? So take a look at this. This is essentially just to sum up. So this is everything that you guys have done so far. This is just summing up what we've talked about. So if you ever want to go back and just like look to review, this is a good spot to look because this is all the angle relationships that we've talked about so far. This is an inscribed angle, so it would be double. All right, this is inside, so you do what with the two arcs? Add them, and this one's exterior, so you do what? Subtract the two arcs. Good. And if it's two tangents that are both on the outside, what do you have to do first? Like if it were, instead of this one going here, what if it were two tangents like this? What would you do to find this arc if they only gave you this one? Subtract from 360, yeah. Because if they're two tangents, that means it has to be the whole thing. Good. All right, so how would we put that all together then to find the measure of arc AF? So arc AF is over here. And we can't figure that out yet because we don't have enough information, but what do we know? What could we figure out?
Angle FED.
Bianca, where do you want to start?
Wouldn't angle DEB be 80?
80, how?
Because it's half of an arc.
Okay, so you're saying this is 80? It would be, okay, then from there, what would you do? Is that right though?
No, because it'd be AF and 160.
So, yeah, so we would have to do AF and this one added together to get this one. So we can't say that quite yet.
Wait, what about 110 to find the arc ADC?
Okay, so to find arc ADB or ADC?
ADC, like arc ADC.
ADC?
Yeah, because they give you the.
But C is over
Oh
here.
no, I mean ADB.
ADB? Okay, so to find arc ADB,
110 times 2 is 220.
110 times 2, so the whole thing is 220 right there.
And then subtract it from 160. Well, you can just keep
To
it like
figure
that.
out what?
80.
Okay, so to get arc AD, if the whole thing is 220 and this piece is 160, what would this have to be?
60.
Okay, so that's 60. Now from here, Bianca, we can figure out one of these because what do we do with these two angles? Add them together. What's 60 plus 48?
108.
108. And then I divide that by
2.
and that gives me 54. So this angle is 54, which means this one is also. From there, how can I figure out angle E?
Are they equal 1?
Which equals 180? like one of these plus 54 is 180, right? So this would be 180. Alright, so I'm gonna back up for just a second. So we got 60 because Jennifer told us if we take this whole arc, it's this angle 110, because that's an inscribed angle. So that's 220, the whole thing. So then we take 160 and subtract 220 to get 60 here. And then we can add these two. Let me do this in a different color, sorry. So we add these two and get 108 and divide by 2 to get those, which is 54. So once that's 54, now this right here makes what kind of line? Straight line, which means it's worth how much?
180.
So then I can figure out this by doing
180 minus 54, which is 126.
so this must be 126, which means this is also, okay. So I can keep going down that path, but I'm pretty sure right now I have enough information to figure out arc AF. How?
126 times
I can't do 126 times 2 because this is not an inscribed angle, it's not on the vertex. But I know a whole circle is what?
360.
360, and don't I have this
Yeah.
and this?
Yeah,
Yes?
you just
So
did
what's
it.
48 plus 220?
268.
268. So then what would I do to figure out this missing piece?
360 minus 268. 90.
92.
So AF must be 92.
How come you didn't add 60?
Because we knew the whole thing was 220.
How'd you know that?
Because this is an inscribed angle, because it's on the circumference of the angle. So 110 doubled is 220. So you can double it. Let me go back for just a second, because people are starting to make, like, remember that to double it, where does the vertex have to be? On the outside of the, like on the circumference of the circle. Okay, so if it's inside the circle, you have to use the adding together relationship. If it's on the only time you can double it is if it's on the outside of the circle. So just keep that in mind. Okay, so we knew that this one was 110, so then this arc had to be 220. And if this was 220 and this is 48, then you just add those and subtract from 360 to get 92. So did we really even need to figure out any of these? No. It's good that we did, because it could have asked us for any of those. But once you figured out the 220, we could have been done. Okay, so at your boards, try these before you go out. This one is 84. Right here is 84. And this one is 58. Okay, go.